Hi, I'm Morgan, and today I'm going to be showing you a limiting reactant problem. So the problem that we're given is when a 2.50 gram strip of copper metal is placed in a solution containing 3.00 grams of silver nitrate, the reaction is, and then it gives you the balanced chemical equation. And our question, we have a three-part question, so we need to find out which reactant is limiting, how many grams of silver will form, and how many grams of excess reactant will remain. So, all right, cool. So to set this up, can you back it up a little bit so you can see the chemical reaction? So to set this up, we need to do two fences to figure out which reactant is limiting. We do one fence for each reactant. So the first one we're going to start with is the Cu, and we are going to start with how much Cu we're given. So we're given 2.50 grams of the copper. So we'll start with 2.50 grams of copper. And then we need to convert this to the to moles of copper. So to do that, we're going to put 1 mole of copper, and then the molar mass of copper goes in the bottom, and that is 63.55 grams. And we just get this from the periodic table. That's just the molar mass of copper. So now that we have moles of copper, we need to use the mole ratio to switch our elements. So we're going to switch from copper to silver. Now the way you can do this, you can actually flip to either product, but if you look ahead in the problem, you can see that part B is asking us about silver anyway. So we're going to use the silver. So we're going to put 1 mole of copper on the bottom so that that will cancel on the diagonal, and then we have 2 moles of silver. So we're going to do 2 moles of silver. And then the last step in this fence is just to convert this to grams. So we're going to put 1 mole of silver on the bottom to cancel out the moles, and then we're just going to put the molar mass of silver on the top, which is 107.87 grams silver. And then the moles will cancel, and we'll be left with how many grams of silver. So this fence tells you that if you use 2.50 grams of copper, this is how much silver it can make. And when you work, this is when it's all set up, you just divide and then multiply, and that will give you 8.49 grams of silver. So now we're going to do the same thing again, except this time we're going to start with our silver nitrate. So it's the same setup, except you're going to use this element first. So we start with how much we're given, which is 3 grams. We're given 3.00 grams. And then we're going to do the same thing, convert it to moles. So we do 1 mole. And then we're going to divide by the molar mass, which is 169.88. And I just calculated this using their molar masses in the periodic table and adding them together. And just remember to multiply the mass of oxygen by 3 because it's got the subscript. And then we're going to do the same thing using the mole ratio. So in this one, our silver nitrate goes in the bottom. There's 2. Oh, sorry. Yeah, so we have 2 moles of the silver nitrate, and then again we're going to use silver, so we have 2 moles of silver. And then our last step is exactly the same, you're just converting this to grams. So when you calculate all of this out, again, you're going to divide and then multiply by 2, divide by 2, multiply by 107.87, and the answer that you're going to get here is 1.90 grams of silver. Now if you look at these, you can see that you have 8.49 grams of silver, and then you have 1.90 grams of silver, and because this is the smaller number, you can tell that this is going to be the limiting reactant, the silver nitrate, because it's going to produce less of the silver, sorry. I don't know why I keep saying gold. Less of the silver. And so your answer to part A, you have to make sure that you write out the full answer. Just this math isn't enough. You need to say AgNO3 is limiting. And that's the answer to part A. And then for part B, you already have all of the work done. You just need to write the answers. The question is how many grams of silver will form. And if you look, it would be the same math that we just did, where you take the limiting reactant and you convert it using the same math we just did, and so your answer to part B is 1.90 grams of silver. And this is the theoretical yield. So the theoretical yield, what that means is that if this reaction happened entirely and perfectly and everything went to completion, the maximum amount of silver that could be formed is 1.90 grams. So that's why that's called your theoretical yield. And then the last thing we have to do is part C, which is asking how many grams of the excess reactant will remain. So I'm just going to erase this and this. So for this one, we're going to do another fence, and there's actually two ways that you can set it up. The way that I like to do it is we just found out that the 3 grams of silver nitrate is our limiting reactant, so I like to start with the 3 grams of silver nitrate. The other way that you can, and the reason I like to do it this way is because for me, this is how much of the limiting reactant you're using, and then we're going to find out when you use this much of the limiting reactant, how much of this is also going to be used. The other way that you can do it is start with the 1.90 that we just calculated in the last one, and start with that here, and then you're calculating if we're producing 1.90 grams, how much of the copper are we going to use? So, so you can also set it up that way if you prefer, but I like to set it up this way. So we start with our 3 grams. And then once again, we're going to convert that to moles. So we do 1 mole of AgNO3, and then the molar mass again is 169.88 grams. Now this time, instead of converting it to the silver, we're going to convert it to copper to figure out. Oh, whoops, sorry. Yeah, so instead of converting it to the silver like we did the first time, we're going to convert it to copper to figure out when we use this much silver nitrate, how much copper are we going to use? And so the mole ratio here is 2 moles of the AgNO3 for every 1 mole of copper. And then for the last step, we are just converting the copper to grams. And when you, so the molar mass of this is 63.55 grams of copper. And then when you work all this math out, you divide, and then you multiply, you end up with 0.56 grams of copper. Now, this isn't the final answer. What this number tells you is that this is how much copper is being used, but the question is asking how much is going to remain afterwards. So the last step is to take how much copper you started with, which is 2.50 grams, and subtract the amount that you use, which is 0.56 grams. So your final answer for part C is 1.94 grams of copper. And that's your answer.